Hi everybody, solving paper 1R 23, which diagram shows light ray correctly reflected from mirror C, because angle of incidence is equal to angle of refraction. Name equipment needed to measure angle of incidence on a ray diagram. It is protractor, light from a laser on Earth reflects off special mirrors on Moon. Graph shows data from light sensor attached to laser. First peak shows when light leaves laser, and second peak shows when light has returned from Moon. Determine time taken for light to travel from Earth to Moon and back again. So it starts here at 0.5 second, and here is the second peak at 3 seconds. So the difference is the time taken to travel to Moon and back again, which is 2.5 seconds. Light speed given, calculate total distance traveled by light from laser, and it gives us the equation, so we can say that this total distance is equal to velocity times time. And note here that it is in kilometer and unit is needed in kilometer, so we'll not convert. And the result is calculate distance from Earth to Moon. It will be the total distance divided by 2, as this distance is calculated by multiplying the time of traveling from Earth to Moon and back again. So half this distance will be only the distance from Earth to Moon. So answer will be diagram shows orbit of Earth around Sun. Draw orbit of Earth's Moon on diagram. It will be circle, and here is the Moon. Certainly you should make the size less than the Earth. Draw orbit of comet on diagram. Comet has elliptical orbit whose focus is at the Sun. Earth orbits Sun in 365 days with an orbital radius of 150 million kilometers. Calculate Earth's orbit speed. V equals 2 pi r over t, so 2 pi r times 150 million, okay, over t, which is 365 times 24 times 3600 to convert it to second as it requires in the answer. Force keeps Earth in orbit around Sun is the gravitational force. Describe evolution of Sun from first stage to final stage. Cloud of gas and dust, protostar when gravity equals radiation pressure, red giant as it is mass less than 3 solar masses, then white dwarf, then black dwarf. Diagram shows balloon with mass attached held at rest just below the surface of a deep pool of water. Balloon and mass are released. Graph shows velocity time of balloon and mass as they fall through the water. Use information from graph to determine terminal velocity of balloon and mass. It's over the 8 by 1 small square, and every small square here is 2 over 10, which is 0.2. So terminal velocity is 8.2 meter per second. Explain how balloons reaches terminal velocity. You should use idea about forces acting on balloon. Firstly, weight is greater than drag forces, and there is a resultant force downward. Acceleration due to this resultant force increases with velocity, velocity increases as acceleration increases, but as the velocity increases, drag also increases. So now weight will be equal to the drag and resultant force will be equal to 0, and there will not be an acceleration, and V becomes constant, which is the terminal velocity. State formula linking pressure difference, height, density, and gravitational strength is delta B equal to rho G delta H. Calculate increase in pressure on balloon when it reached 25 meter in water. We will substitute in the previous equation. Here is the density, here is G, and here is the delta H in meter, 250,000 Pascal. At surface, atmospheric pressure is 10 to 5 Pascal. Show total pressure at depth 25 is 3.5 times 10 to 5 Pascal. We will just add this atmospheric pressure to pressure due to water, so it will be 2.5 times 10 to power 5 plus 1 to power 5, 3.5 Pascal. At surface, pressure is 10 to power 5 Pascal. Balloon has volume of 0.46 meter cube. Calculate volume of balloon at 25 meter. B1 V1 equal B2 V2, which is Boyle's law. So it is 1 B2 here is 3.5. We have just calculated time V2, which is required. Use your calculator, the answer will be. Student investigates how current in filament varies with voltage. Student has equipment, filament, lamp, cell, resistor, meter, voltmeter, connecting wire. Draw circuit diagram that student could use for this investigation. Here is the cell, here is the battery, sorry, the filament, and here is the variable resistor. You can make it and here is the ammeter, which must be connected in series, and here is the voltmeter, which is connected in parallel to the filament lab. Table gives result. Plot this result on grid. We have here voltage on x-axis. First point is 0, 0, second one is 1 and 0.38. Here 0.2 divided by 10 gives the value of 1 small square, which is 0.02. So when we want to spot the 0.38, we should first find 0.3, which is the half distance above the 0.2, and for 0.08 it will be 4 small squares, because if we multiply 4 by 0.02 it gives us 0.08. So here is 0.3 and 1, 2, 3, 4. Here is 0.38. So here's our first point, second point, because first one is 0, 0. We can follow same way to plot the other points. Draw curve of best fit. We will just join these points together. Filament of lamp is made of metal. Students suggest a straight line on graph is more appropriate than curve because current is directly proportional to voltage. Suggests how student could improve investigation to find out whether straight line or curve is more appropriate. He needs to find more data for wider potential difference range so he can extend the graph more than this range. Explain why students shouldn't expect the current to be proportional to voltage for this filament lab, because we know for the filament that by increasing potential difference in temperature increases, and increase in temperature cause a increase in resistance, so it goes out of the straight line pattern. Photograph shows nuclear fusion reaction. Describe difference between nuclear fusion and fission. Fusion, two small nuclei join to form larger one. Fission, one large nucleus split by neutron hitting to form two small nuclei. At ITER, hydrogen 3 and hydrogen 2 will be fused into helium and another particle labeled X. Complete nuclear equation for fusion of hydrogen 3, hydrogen 2. So we atomic number and mass number should be conserved before and after the reaction. So as we get to here, it is balanced, and so atomic number for X will be 0, and for mass number here is 5, here is 4, so this should be 1, which is certainly the neutron. Discuss potential safety advantage of fusion compared with fission. You should refer to products of fusion and fission of uranium. Fusion has no radioactive waste, so has no need for shielding and has no waste storage problems and does not cause mutation or cancer. Half-life of radioactive isotope is 12 years. Activity of it is 120 kilobecquerel. Calculate activity of sample after 84 years. After the first 12 years, 120 will be decreased to 60, and after the second 12 years it will be reduced to 30, and so on till the fourth 12 years or fourth half-life. It will be 7.5. 4 times 12 years is the 40 years that he asks about. So answer will be 7.5 kilobecquerel. Diagram shows a small computer in two different cases, X and Y. Electronic chip in computer is hot when in use. Each case is designed to cool the computer chip. Case X is made of white plastic and has fan. Case Y is made of black painted aluminum metal and has no fan. There is a metal block that is in contact with the case and the chip. Here is the case, here is the chip. Explain main method of heat transfer from chip to surrounding for case X. So case X is made from plastic, and plastic is poor conductor, so we can exclude the conduction to be the main method of heat transfer. And as it has fan, it indicates that convection is the main method of heat transfer, where fan aids in moving air current inside the case. And as the metal case is white, white is good reflector, so cannot uh, made an absorption for heat inside the case. With respect to aluminum case, as aluminum is metal, so it is good thermal conductor, and as it is black, it is good absorber and good emitter, so it absorbs thermal energy inside the case well, and it emits it well to surrounding. So mechanism in case Y is conduction. State formula linking power, current and voltage. V equals IV. Small computer operates at voltage and current. Calculate power. So V would equal 5.1 times 2.9. Answer will be 10.8 watt. Diagram shows path of ray of light. Measure angle of incidence for ray at point K. Angle of incidence will be the angle between the normal and the incident ray. Measure it with your protractor and find the answer. State formula linking refractive index, angle of incidence, and angle of refraction. Block has refractive index of 1.52. Use formula to show that angle of refraction is about 30 for the ray at point K. You will use the previous formula that we have just write to substitute. Sin I here will be the angle of incidence, which is, by the way, 51 sin R. So R will be sin -1, which is 30 degrees. Refractive index of block is 1.52. Calculate critical angle of block. We have that sin C, where C is the critical angle, is 1 over n, so C is equal to sin minus 1 1 over n, so it's equal to state what happened to ray at point L. So as we found angle of refraction to be 30, this angle will also be 30 from its geometry, and this will be 70. So the angle of incidence on this interface will be 70, which is greater than the critical angle, which we have just calculated and found that it is 41. So as the angle of incidence is greater than C, the ray will be totally internally reflected inside the glass. Okay, so there is total internal reflection. Student wants to determine density of air using a regular shaped balloon. Balloon has a label stating that volume of balloon when full is 490 centimeter cube. This is part of student method. Measure mass of empty balloon, filled balloon with air, measure mass of full balloon, subtract mass of empty balloon from mass of full balloon, name equipment of equipment the student could use to measure mass of balloon. It is balance. Suggest how student could improve reliability of their data. He could repeat the procedure and average the result. Table shows the student result. Here is the mass of empty balloon, mass of full balloon, and volume of air. Calculate density. So we will find first the mass of air, which is the difference here. So mass of air equals 0.61 gram, and here is the volume, so density of air equal 0.61 over 490, and the here is the unit should be gram per centimeter cube. Describe how volume of balloon full of air could be measured using a large beaker and some water. Use a diagram to help. Put some water in beaker, measure its volume, name it V1, submerge balloon filled with air and water. You can use a block, tie the balloon with the block, and this block should have a definite volume. You should know the volume. Remeasure the volume after submerging the balloon in beaker and name it V2. Subtract V2 minus block volume that you used to force the balloon to be submerged under the water. So V2 subtracted from block volume and then subtracted from V1, which is the volume before submerging the balloon. Teacher demonstrates penetrating ability of alpha, beta, and gamma. State precaution to make sure they are working safely. Use tongs or leave a distance between students and sources, and make the exposure time as short as possible. State name of detector teacher use. This Geiger mirror detector. Draw cross in table to show which type of radiation cannot penetrate each material. Alpha cannot penetrate all of the three, 10 centimeter of air, 2 centimeter of aluminum, and 10 centimeter of lead. Beta can penetrate 10 centimeter of air, but not 2 centimeter of aluminum and not 10 centimeter of lead. Gamma can penetrate 10 centimeter of air, 2 centimeter of aluminum, but not 10 centimeter of lead. Alpha particles has mass traveling with speed. Calculate kinetic energy. The answer will be state work done on alpha particle when its speed is reduced to zero by sheet of paper, so it loses all of its kinetic energy that we have just calculated, and work done by the sheet to stop alpha particle is equal to the energy lost by the alpha particle from principle of energy conservation. So it will be the answer like I have just calculated in I. State which energy store of paper increases when alpha particle is stopped. It is the internal energy store, which is then transferred in thermal or light energy. Diagram shows forces acting on firework at takeoff. Here is the thrust, here is the weight. Calculate magnitude of resultant force. It will be the difference between the two. So 28 minus 1.6. State formula linking resultant force, mass, and acceleration. F equals m times a. Mass of fireworks is 160 gram. Calculate acceleration of firework. So as we have the resultant force to be equal to 26.4, so acceleration will be 26.4 over 160, and as he needs unit in meter per second, we should convert it to kilogram because this is in Newton, so the answer will be. Explain how acceleration of firework changes between takeoff and running of fuel. Assume thrust stays same as firework burns the fuel. Running of fuel decreases mass and hence weight. So as weight decreases, resultant force increases because it is equal to thrust minus weight. And as the resultant force increases, A increases. But because of air resistance increases as acceleration or velocity increases, so resultant force, which again is the thrust minus W, will decrease because this thrust will decrease when we subtract it from the weight and the air resistance. So and as the resultant force decreases because of increasing the air resistance, the A decreases. So A first increases and after a while it decreases. Firework make sound with constant frequency. As firework moves upward, People on ground notice frequency changes. This is called the Doppler. Explain Doppler. As the rocket moves away from observer, sound wave is stretched. Distance between wavefronts increases, which means lambda increases, so f decreases because v is equal to lambda f. Diagram shows experiment done by Orsted. Diagram show position of 8 compass needles around wire with no current. Compass needles lines up when there is lines up and show direction of Earth's magnetic field lines. Diagram 2 shows position of same needles when a current is in wire. Explain why compass needle turn when current is switched on, because there is magnetic field due to current in the wire, and the needle follows the magnetic field lines whose direction is clockwise. As we see here, the north of the needle points in this direction or in the clockwise direction, so the field line is in the clockwise direction. Using evidence from compass needles in diagram 2, draw on diagram shape and direction of magnetic field line as we just discussed. Here is a circular shape and here is the direction. Suggest what happened to field when current in wire is reversed. It will be reversed, so current in wire is turned off, shows wire plays in uniform magnetic field. Current is now switched on. Draw an arrow to show direction of force on wire. So here is the direction of magnet, and we will use Fleming left hand rule because it gives us the electromagnetic force when a wire with a current is in a magnetic field. So as the current here is in out of page direction, we will use our hands, make the first finger in the direction of the field, the second finger in direction of current out of page, so we will find that the force is upward. Power supply is replaced by an ammeter, wire is moved and current is detected. Explain which direction wire is moved in magnetic field to produce current in wire. So it will be upward or downward, because here is again the direction of field, and here is the wire connected to ammeter. As there is deflection in the ammeter, so there must be current. This current could be into page or out of page, so movement will be in the third perpendicular direction, so it will be upward or downward. Explain why current is produced in wire when wire is moved in magnetic field, because wire cuts field line with time, so there is a rate of change of magnetic field lines cut. With this rate of change causes induced electromotive force in the wire. Okay, here is everything. Thank you for watching, share and subscribe, and wait for the new videos.